So this baseball is thrown with initial velocity of 40 feet per second, initial height of 6, which then gives us this formula right here for the height of the baseball. Then find the average velocity. So for one thing, we're going to need to take the derivative to find the velocity. So that's going to be negative 32t plus 40. And then during its flight through the air. Not quite sure that's how you spell through in this situation, but that's okay. This isn't English class. So it's going to start at a height of 6. It's going to go up, and gravity is eventually going to bring it back down. So this is going to be at time equals 0, but this one is time equals what? So for that, you could graph that function, negative 16x squared plus 40x plus 6. And the window from, well, I want to be able to see this 0, so I'll put negative 1. And then for a baseball flying through the air, I would imagine 5 or 6 seconds. And then maybe it'll go 100 feet in the air. Okay, so the person wasn't quite as strong as I thought they were. So this is going to be like 2 point something seconds. So between 2 and 3, and my guess is 2 point something. So this t right here is 2.642. So then find the average velocity. So that means integrate the velocity function over the time interval from 0 to 2.642, and then divide by the length of that interval, which would be 2.642 minus 0, or just divide by 2.642. So just like when you find the average, say you find the average of 3 numbers, then you add them up and you divide by 3, that's how you find the average. Well, that's what we're doing right here, because this is adding up all the velocities and then divided by the total amount of time that it took, and that will average them. So this is going to be the 1 over 2.642 stays there. And then the antiderivative of this would be t squared over 2, which is going to be negative 16t squared. And then this would just be 40t. And then evaluate from 0 to 2.642. So let's see. If you substitute the 2.642, so that's going to be negative 16 times 2.642 is squared plus 40 times 2.642. It equals that much, negative 6.003. So negative 6.003, and when you substitute 0, those are both going to be 0. Then it still needs to be divided by this. So then divide by 2.642, and it's a negative 2.272. Negative 2.272, and then this would be in its velocity, so it's in feet per second. Now, what's really happening here is it's starting with initial velocity of 40 feet per second. It's going to be going up. Its velocity is getting smaller and smaller and smaller until right here, the velocity is 0. And then it's going to go down, and the velocity is going to be increasing, but it counts as a negative as it's going down. By the time it gets right there at 6 feet, the average velocity is 0. Because this would all be positive velocity, this is symmetric and it would all be negative, so they're going to cancel each other out. So what we just found is basically how much velocity is left right here. So as it goes from the last 6 feet to the ground, then it's an average of negative 2.272 feet per second. And the negative just means that it's going down.